Let us calculate the kinetic energy of a rolling object. This body rolls on the flat surface. If this is the center of mass velocity, omega is the spin for rolling. If the surface is stationary, Vc is equal to r into omega, where r is the radius of the rolling object. The kinetic energy of the rolling body is equal to kinetic energy of translation plus kinetic energy of rotation. The translational kinetic energy is equal to half mvc square, and the rotational kinetic energy will be equal to half ic into omega square. Then the total kinetic energy, this is total kinetic energy, is equal to half mvc square plus half ic into omega square. Ic into omega, omega is equal to Vc by r for pure rolling. In this way we are getting half mvc square plus half. We can write Ic, the moment of inertia about the center of mass axis, as m into k square, where k is the radius of gyration. Writing Ic is equal to mk square, is multiplied with Vc square by r square. In taking mv square common, we will get 1 plus k square by r square. This is one formula. Furthermore, we can write the total kinetic energy is equal to half m Vc square plus half ic into omega square, and we can substitute Vc is equal to r into omega. Plus ic into omega square by 2. You can take omega square by 2 common, and inside the bracket we have mr square plus ic. Mr square plus ic can be written as ip. Omega square by 2 into ip. So in this way we are getting the expression that the kinetic energy of the rolling object is equal to half ip into omega square, where ip is the moment of inertia about the instantaneous axis of rotation. That is the lowest point of the rolling object. You can get the same expression from this formula. Suppose we can get the same expression by using this formula. We write k is equal to half mvc square. This is 1 plus k square by r square. You write Bc is equal to r into omega. This is k square plus r square by r square. And you are getting half m omega square k square into k square plus r square. Omega square by 2 m k square plus m r square. This is IC and this is m r square into omega square by 2. Then this is none other than IP. In this way you are getting the same answer of the total kinetic energy, which will be equal to half of the moment of inertia of the rolling object about the instantaneous axis of rotation, that is P, into the square of the angular velocity of the rigid body. So here kinetic energy of the rolling body. This can be written as translational kinetic energy. Therefore, kinetic energy is equal to half mv square 1 plus k square by r square multiplied with this. This can be written as translational kinetic energy into 1 plus k square by r square is equal to rotational total kinetic energy. So the total kinetic energy is equal to translational kinetic energy into this factor. So the translational kinetic energy by total kinetic energy is equal to 1 plus k square by r square. And therefore the rotational kinetic energy upon the total kinetic energy can be written as the rotational kinetic energy by total kinetic energy. We can write 1 plus r square by k square. You can prove. You can write rotational kinetic energy upon the translation total kinetic energy is equal to half IC omega square by half mvc square 1 plus k square by r square. But IC is equal to mk square by mvc square 1 plus k square by r square. Mm will be getting cancelled and you substitute BC is equal to r into omega for pure rolling. So Vc is equal to r into omega into 1 plus k square by r square. So you are getting this term after cancelling omega square in numerator and denominator, k square by r square into r square by k square plus r square. R square will be getting cancelled. So omega square will be getting cancelled. Well, this will be k square by r square into r square by k square plus r square. You will get this term after cancelling omega square in both numerator and denominator. Here r into omega square of this. So here you are getting r square into omega square. Cancel this omega square In numerator and denominator you are getting k square by k square plus r square. So rotational kinetic energy upon total kinetic energy is equal to k square by k square plus r square. So this expression is wrong, you have to correct it. This expression is wrong, you have to correct it. This will be k translational by total. K total is equal to 1 upon 1 plus k square by r square. That will be equal to r square by r square plus k square. And k rotational upon the total kinetic energy will be equal to k square by r square plus k square. So let us tabulate these two formulae. Let us tabulate the obtained formulae for the kinetic energy of the rolling body. The kinetic energy of the rolling body is equal to translational kinetic energy into 1 plus k square by r square. Therefore, the translational kinetic energy upon rotational kinetic energy is total kinetic energy is equal to 1 upon 1 plus k square by r square, that is equal to r square by r square plus k square. And the ratio of the rotational kinetic energy and total kinetic energy will be equal to k square by r square plus k square. If you want to calculate the ratio of translational kinetic energy and rotational kinetic energy, you can get half mvc square by half ic omega square. Half will be getting cancelled. mvc, instead of vc you can write r into omega. Instead of ic you can write mk square into omega square. Therefore, the ratio of translational kinetic energy and rotational kinetic energy can be written as r square upon k square. So using this formula, directly you can solve some problems. Let's take an example. This is a solid sphere of mass m and velocity of the center of mass is bc, that's equal to v. What fraction of its kinetic energy, means total kinetic energy, is translational, and what fraction of the total kinetic energy is rotational? So you can use the derived formula directly. Kinetic energy of translation by kinetic energy total is equal to 1 upon 1 plus k square by r square. IC is equal to mk square for the solid sphere is equal to 2 by 5 mr square. Therefore, k square by r square is equal to 2 by 5. So substitute k square by r square is equal to 2 by 5 to get the ratio of the kinetic energies as 5 by 7. Then the rotational kinetic energy upon the total kinetic energy will be naturally will be equal to 1 minus 5 by 7, that's equal to 2 by 7.